Hey guys, Mrs. Traver here. We're going to walk through our notes on absolute value equations and inequalities today. So I've got to start off with the definition of absolute value. Absolute value is the distance that any point is away from zero. And because it's a distance can never be negative. I don't talk about the distance between two cities, and then if I were to drive back to where I'm from, I wouldn't talk about that as a negative distance. So this is always going to be positive. Always positive. So let me give you an example here on a graph, and I think it'll make a little bit more sense. So if I have this graph, and if I'm talking about the absolute value, and by the way, it's written like this, with two large lines. They're not ones, they're taller than the rest of the numbers. Make sure you draw them taller than the rest of the numbers, because say you have the absolute value of 1 or of 11, it ends up looking like 1,111, for example. So I've got the absolute value of 2 on this one. What this is really reading is, if we can read this with the distance word, I'd say the distance that 2 is away from 0. Well, let's mark 2. And the distance that it is away from 0 is 2 away, so 2 units away. So the absolute value of 2 is 2. Similarly, if I looked at the absolute value of negative 2 is over here. It's also 2 units away. It's also 2 units away, so this is positive 2 again. So now we've got a feeling for what absolute value looks like. We'll do a few examples of these guys. Let's do our first one as absolute value of x equals 3. So on this one, what I'm saying is the distance x is away from 0 is 3 units. So if that's the case, either x was positive 3 or negative 3. And that's exactly how I write my answer. X equals 3 or x equals negative 3. So notice the way that I can play this off is when I have an equation and I'm solving for a variable inside the absolute value, first get your absolute value by itself. It already is done here. And then take the inside of the absolute value and set it equal to the positive and negative of the right side of the equation. That was a mouthful, so let's do another one and it'll start to be a little bit better. Sample 2 is the absolute value of n minus 5 equals negative 2. All right, absolute value of n minus 5 equals negative 2. I want to get n by itself before I do anything else. So let's do that. Let's add 5 to both sides. And now I'm left with the absolute value all by itself. We're in a good spot here. Now we can solve just like we did in the last one. Either n is positive or negative 3. Good there. Let's do another one. How about if I had absolute value of 3x minus 2 equals 7. On this one, get your absolute value by itself first. So let's add 2 to both sides. 3x, or absolute value 3x, equals 9. Now my absolute value is all by itself. So I need to split it up at this point. So either 3x equals 9 or 3x equals negative 9. So once you get your absolute value by itself, then you split it up into the or statement. And from here I can solve either x equals 3 or x equals negative 3. Let's do a couple more. I know I'm moving fast. Always use that pause button if you need it. Here's the next one. If I had the absolute value of negative 2x plus 1 equals 3, I've already got my absolute value by itself in this case. So let's split it up into equals 3 and equals negative 3. So negative 2x plus 1 equals 3, or negative 2x plus 1 equals negative 3. And I have 2 equations to solve for. Pause the video and see if you can match mine. And here's what mine looks like. So I've got x equals negative 2 or x equals 2. Check your work with mine. Here's the last one we're going to do. It's going to look a little bit different. So I've got the absolute value of 3x minus 6 minus 5 equals negative 7. All right, I want to get absolute value by itself to start. So let's add 5 to both sides. I've got the absolute value of 3x minus 6 equals negative 2. Before we move on, I want to look at see what we have here. Notice that we have the absolute value of something equals negative 2. So the distance that this thing is away from 0 is negative 2. Wait a minute. Distances can't be negative. So this one, we can stop right here and say that there is no solution. So if you have an absolute value by itself equals a negative, we just set up here, that can't happen. They're always positive. So this one is a no solution. So far we've covered everything absolute value with equations, equal sign, equal sign, equal sign, equal sign. So now I want to look at it with inequalities instead. So here's what's going to be a little bit different. All right, let's see. If I have the absolute value of some number x and it's less than, let's think about what this would look like. So what I'm saying here is the distance that x is away from 0 is either a away, is less than a away, or is less than negative a away, because I'm not sure if it's positive or negative. So this is saying the distance x is away from 0 is less than a away. So it's anywhere in between here. It's anywhere in between these 2 points. And we just got done a little bit ago talking about inequalities. This looks like an and statement. Matter of fact, every time we have a less than or a less than or equal to, this is going to give us an and statement. Similarly, if I have x is great, or absolute value of x is greater than a, absolute value of x is greater than a, it says the distance x lives away from 0 is more than a. So it lives bigger than a away or smaller than negative a away. So everything that is a greater than or equal sign is an or statement. So we're going to be able to convert all of our inequalities we can convert all of our absolute values into inequalities. Let's do a few examples of these. So if I have the absolute value of c is greater than 75, it's a greater than 75 away. So let's work it out kind of like we did our inequalities. Either the absolute value of c is greater than, or it's c is greater than 75, so that's just pulling the positive and the positive. Or normally I just grab the negative of 75 over here, but be careful. If you grab the negative of 75, then we also have to change our inequality. And then the last thing I need is an and or an or. This is a greater than, and our greater thans are or statements. So at this point, I can graph it. Either c is, let me get my numbers down. Either c is greater than 75 away from 0 or less than negative 75 away. Let's do another one. This one is absolute value of a plus 3 is less than 7. So I've got absolute value of a is less than 7. I'm sorry, how about 7 minus 3? Why don't I actually subtract 3? This should be a 4. My bad. So either I have a is less than 4, and then this is a less than, so it's an and. A is less than 4, and a is, switch the sign and switch this to negative, greater than negative 4. A is less than 4, and a is greater than negative 4. So since this is an and statement, it's going to be an in-between inclusive. So I've got open dots again. Greater than negative 4 shaded this way, less than 4 shaded this way, so shaded in between. We'll do one more of these guys and call it a day. Oops, what is going on here? Let me finish this up on the next video. On this last video that we've got, or on this last question, we're gonna keep it positive or keep it negative. I'm running out of time, so I'll leave you there.